Hi everyone, and thanks very much for being here today. Thanks to ICAM for giving me the opportunity to share our research with you all. The Goa DogPop project is a collaboration between the University of Edinburgh and the Worldwide Veterinary Service, and it's funded by the Dogs Trust. The project aims to measure the impacts of sterilisation on free-roaming dog populations in India. Typically, impacts of sterilisation have been measured post-intervention, the neutering occurs, and then the population is monitored over a period of time. Whilst this is really important, we have no way of knowing what would have happened in that population if the neutering hadn't occurred. So if something, say like a global pandemic occurs, we don't know if the effects we are seeing as a result of the pandemic or the neutering. And the best way to confirm this is to have a comparable control population. There was a fantastic scoping review performed in 2017 by some authors who are probably here today. This demonstrated that there were very few studies measuring the population impacts of sterilisation, and that there were actually no studies at that time with a randomly assigned control group. So with the DogPop project, we set out to provide more robust evidence for the population impacts of sterilisation. We conducted surveys prior to neutering, which means we had an idea of what the baseline populations were like prior to the intervention. Each neuter site had a corresponding control site where the population was monitored but no intervention occurred. And we did this over 5 replicates. If we detected certain trends in one site, it could be down to chance. However, if we see the trend in multiple sites, we have much more robust evidence for making conclusions. So with this pre-intervention baseline, a control population and 5 replicates, it means that the results of the DogPop study will provide good evidence for the effects of dog population management. And as a global pandemic did in fact start right at the beginning of our study, we have been especially thankful for our control sites. Goa is one of the smallest states in India on the southwest coast. We chose 10 inland sites away from the tourist beaches, and they were matched into 5 pairs. These pairs were matched on geographical location to ensure that they experienced similar weather conditions, matched on their environment in terms of types of land use, their human population and their dog population as calculated by the number of dogs vaccinated by mission rabies over previous years. So within each pair of sites, one of these sites was randomly assigned to having the neutering intervention. Each site itself was divided into 3 to 5 survey zones. Between May 2020 and January 2023, survey teams performed over 3,000 surveys over 13 rounds. All sites had 3 rounds of surveys prior to neutering, covering about 7 months, and then 10 rounds of surveys after the neutering, covering around 2 years after the neutering had started. Each round comprised of 8 surveys, 4 in the morning and 4 in the afternoon per survey zone. We had 7 surveyors, and 5 of these were present for the whole of the study. All of the surveyors surveyed all of the sites. Surveyors collected the GPS location and data about every individual dog seen on the survey on the WVS smartphone app. After the first 3 rounds of surveys, we started neutering. The WVS team created 4 field sterilisation clinics near to the neuter sites. Teams of experienced dog handlers captured dogs within the study areas, mainly by net catching, some by hand if they were friendly, and cage trapping was used where necessary. Capture locations were recorded to ensure dogs were returned to the capture location and to confirm that dogs were caught within the study areas. The teams captured and sterilised 4,267 dogs over all 5 sites in about 7 months, and 54% of those were female spays. We did try and focus on females due to their greater influence on population dynamics. You can see from the distribution of this plot showing daily stray dog catches that towards the end of the campaigns, the number of dogs that we could capture dropped off quite a lot. Despite the same amount of effort and teams, it did just become a lot more difficult to capture dogs as the neuter coverage increased. All dogs were ear-notched under anaesthesia so that they could be later identified as sterilised. Using the counts of the ear-notched dogs, these plots show neuter coverage on the y-axis over 13 rounds of surveys for 1 pair of our study sites. We can see that the control sites maintain a low level of neuter coverage, and this is thought to be as a result of private sterilisation of owned roaming dogs. In the neuter sites, the first 3 rounds show that there was not a difference in the initial population between neuter and control sites, and then we see a rise in neuter coverage during the neuter campaign, which is shaded in red. For a very similar pattern in all our study pairs, the neuter coverage in neuter sites did show a slight decline over the study period, but in many sites it was still over 50% by the end of the study. So this might suggest that the study populations had quite a low turnover. There was no significant difference in the rate of decline of neuter coverage in neuter and control areas. The fine-scale temporal resolution in our data demonstrates the seasonality of dog sightings. This plot shows the adult dogs over the 3 years of the study, and we can see that there were many fewer sightings of dogs during the period between May and September, which in Goa corresponds with the monsoon season. So just to give you a quick idea, it is pretty heavy rain, and it's no wonder the dogs don't want to go out in that. We then saw an increase in sightings in the cooler, drier months, and this demonstrates why it's so important to take season into consideration when we're interpreting and comparing count surveys. To assess the impact of sterilisation on dog counts over time, we ran a series of generalised linear mixed models evaluating the neuter impact on all adults, different categories of entire adults, and lactating females and puppies. We allowed the starting count and the slope between time and counts to vary between study sites using random intercepts and random slopes. So first to look at lactating females. The proportion of lactating females is here on the y-axis, and the days after the start of the sterilisation campaign is on the x-axis, so 0 signifies the start of the neutering campaign. This plot shows the raw survey data as points, and you can see that there's quite a lot of variability over time in this data. The lines and the shaded regions on the plot show the predicted proportion of lactating females over time. This is averaged out over all of the study sites and over other covariates. The red line represents the control sites and shows that there was no change in the proportion of lactating females over time. The blue line is showing the trend in the neuter sites and shows that the proportion of lactating females declines over the study period, and that's significantly different from the control sites. It declines from about 10% to about 5%. And so this is what we would probably expect to see after a neutering campaign, and reflects the reduction in entire females that are available in the sites. Next we have the trends in puppy sightings. This plot is very similar to the one before, but instead of proportion on the y-axis we get the puppies per kilometre of road that was surveyed, which is the metric that we're going to use going forward. There's a decline in puppy sightings in both the neuter and control sites, but the decline is significantly steeper in the neuter sites, echoing the reduction in lactating females that we saw previously. Here we also see much wider confidence intervals, which are a reflection of the wider variability in puppy sightings from survey to survey. There was a steady decline in sightings of adult dogs in all sites, with no difference between neuter and control sites. On average, over all sites, we saw a reduction from about 6 to about 4.5 dogs per kilometres of road. As there was no difference between the neuter and control sites, this trend is more likely to be due to a process that is happening in all sites, for example the after effects of a global pandemic, due to lockdowns and closures of food outlets, rather than an impact of the neutering itself. This pattern was reflected in each pair of sites, as you can see from the plot on the right hand side. Each individual box is a study site pair, and we can see by looking at the slope gradients that most sites show this declining trend, and that there are no significant differences between the neuter and the control sites. When we broke down the adults into categories, we saw that there was a decrease in the entire males in the control groups, consistent with the overall trend for all adults. But the entire males were actually increasing in the neuter sites only, so this was significantly different between the neuter and control sites. We saw a similar picture in entire females, where they increased significantly in the neuter sites compared to the control sites. So because there's this decrease in lactating females and puppies, This increase in entire dogs is unlikely to be from increased recruitment from within the site, but this may indicate immigration from external areas. So in summary, despite intense sterilisation effort, there was not a significant difference in adult counts within our neuter sites. We did see an increase in entire adult dogs after sterilisation, which may be a result of decreased territoriality in neutered dogs, allowing entire dogs into the area. There was a decline in lactating females and puppies in neuter sites only, suggesting a decreased birth rate in neuter sites, which may result in fewer puppy deaths. This study demonstrates the need for control sites to fully evaluate impacts of sterilisation. Without these, we may have taken the reduction in the population as being as a result of the neutering. Our analysis is ongoing and we have additional data on community perceptions to come. Thanks very much for listening. I have to say huge thanks to the fantastic Goa DogPop team that have made this project happen despite some really tough times. Thanks very much to all the teams at WVS and Mission Rabies, both in India and the UK, and thanks to my colleagues at the University of Edinburgh. I'm happy to take any questions now that we have time for, otherwise please email me for any more details.